Hi everyone, this is Fengwei from Intel accounting. In this session, I'm going to talk about how to debug account a little bit. If you have any question, feel free just interrupt me, stop me, and ask. Yeah, there's three parts in this session. The first one, we're talking about the account advisor itself debug. Part two, we'll share some common methodology to debug the guest, whatever the guest is, whether it's post-launch, it's pre-launched, or it's SOS. In the part three, we'll only talk about the post-launch guest, because the post-launch guest has some special, unique attribute. So we could use some special way to debug it. Yeah, any software running on the computer, we could use the JTAG interface to debug it. It's same for the account advisor. The common JTAG application trees. I'm not sure the company for the trees 32 software. And also, if you could get it, you could use the Intel ITP. It's another Intel production for the JTAG connector. The special requirement if you want to use the JTAG, the first one is that you may need the JTAG pop on the hardware board, which is not very common for the production. And also, another choice is the DCI interface. If you use the latest Intel SoC, if the BIOS have the DCI interface exposed, you could choose to enable the DCI interface for debugging. And the hardware connection is actually use the USB 3. One of the USB 3 ports it could be used to enable DCI. And a special cable, it's Type A to Type A cable. You could use that to connect the target with your host, and then you could run some connectors in your host. Then could connect to the target board, and the DCI signal will be turned to a JTAG in the SoC internal. Yeah, basically you need some special hardware. Yeah, so for the JTAG is not a very common debug methodology for our company. So it's we only use that to debug the early boot issue or the random system harm issue. And if you use the JTAG tool, there's something you need to be take care. One thing is that symbol loading. Sometimes if you want to do the source level debugging, you need a symbol loaded by your software. It depends on whether the tree32 is used or the Intel IDP connector is used. Different software have different configurations. For example, the tree32, it could handle the symbol offset totally. So it's just very convenient. But some software cannot. You need to do some manual configuration to let the software load the account symbol. That means the host totally support the symbol. And also in our account, to improve the system security, we enable the account advisory location, which means the account could be running in a different address, comparing with the build address. When we build the account, we define our account start address, but in the real hardware, it could be loaded. The account could be loaded in a different address. So all the symbol is built based on the build address, but the runtime address could be another address. So there's some offset between the runtime symbol and the static symbol. So you need to figure out the delta there. So and if you don't want to do source level debugging, for example, you just want to stop the target and check the register or the some state or memory of the target, you don't need a load symbol. So that means you don't need any symbol information loaded by your debugger. Yep. So any question for this page? No. Okay. Next. Yeah. The most common methodology we use to debug our compiler is through the serial port. If you check our ARCON documentation, we see that to debug the hypervisor, ARCON hypervisor, the serial port is a must-have. It's more common than JTAG. In our ARCON development, we require all the platform have the serial port. Whatever it's already there on the hardware, or you may need some hardware rework to have the serial port connected out. And the serial port, the bad thing for the serial port is it could be supported by all OS. Whatever is Linux, it's the VxWorks, Zephyr, Linux all support the serial port. And to use the serial port for the ARCON, first thing you need to enable debug build. If for the release build, we remove all the serial port support from the ARCON. And from the hypervisor, from the serial port of the hypervisor, we could see some logs. If you check our ARCON hypervisor source code, you could see we define different log level, something like errors, warnings, notice, information, debug message. You could choose the different API according to your message level. And also, we have a default message level defined at the build time. All the message level lower than the default level will not be printed out to the serial port because we don't want to flood the serial port with just debugging message. But if you try to debug something, you could change the default log level. So you could allow more debug message print out to the serial port. Or is according to your own debug requirement. Yeah, and also we have the hypervisor console based on the serial port. So you could input some command to let the hypervisor output some information for you. For example, you could check the memory. You could check the pass-through interrupt information, and yeah, something like that. There's a document in our ARCON documentation showing about what kind of command we provide with the ARCON serial console. And also, you could just type the help command on the serial console. It will show all the commands we support. Yeah, here's some example of the serial port. Yeah, this is the this actually is a boot message here. It includes many useful messages. It also is printed out with some with predefined format. For example, here we have the ARCON version and build info. When you try to report an issue, this is very important. So we can know about what issue and what kind of build that issue happens on. And also, there's a scenario and a platform information here. So in this example, we see that it's an industrial scenario, which is running on our TechLink platform. If you look at the message here, the first field is actually a timestamp. So in some case, we could evaluate whether the system is running smooth just by checking the delta time between different message here. For example, if we check these two message, the guests are trying to start the secondary CPU. We have SMT support. Supported it should be very close. So if we look at the timestamp here, it's quite close, right? And also we have the second field here is what physical CPU this message happens, or this event happens on. This is the physical CPU number. And then we have the VM index and the vCPU index here. Because we support the CPU sharing on the same physical CPU, we could run multiple virtual CPU. So we could tell which VM and which vCPU this event just happened on that, right? So this is the basic information about the serial port. So any questions here? Oh, I saw a question on the chat window that whether we could use the GDB to debug the ARCAN hypervisor. No, we don't support GDB. The reason is that, yeah, we do have reason. The reason that we want to keep the ARCAN hypervisor very small, and to add a GDB server to the ARCAN could introduce a lot of line code, and also from my experience, GDB to debug ARCAN is not as fancy as what we expected. For example, we only have serial port available for the hypervisor, and also that serial port will be used as the serial console. Then we need to do some mix between the GDB communication and the serial console. That will introduce some complicated thing here. So we just don't support that. So any further questions? No. Okay. Sure. Yeah, this is a typical command I use a lot to check the guest information, which is the vCPU dump regs. It's still ARCAN shell command, so it will dump all the guest vCPU registers. Here you can see all the vCPU general register will be dumped here, and also we will dump some ISP memory here. It's a guest stack here. Just example, if you want to try it, there's some other command you could use to check what's happening in the guest. Yeah, here's a for the ARCAN hypervisor itself debugger, we just introduce all the methodology available now. Yeah. Now we are talking about the guest debugging. First, we emulate a serial port to the guest. For example, we emulate an L port, serial port to the Linux guest. Our SOS is a Linux, so all the native Linux could use serial port. You could use that with our emulated serial port. And also sometimes Windows could use that to print some message also. That depends, and the emulated serial port actually depends on the hypervisor serial port, because that serial port message will finally should be used to do interaction with the user. So we need a physical serial port on the system. So question on the chat. Okay, this. And when we run multiple guests above the account, we do have different emulator serial port for different guests. So that means we could have 3 or 4 virtual serial ports there, and then we have command to switch different virtual serial port. For example, you could use the VM underscore console one that will connect the physical serial port to the VM1, and if you use the VM underscore console 2, that will connect the physical serial port to the VM2. So you could switch to different VM serial port. This is one debug methodology, and also in some case, you could use the VM exit info to understand the guest behavior. For example, if your guest is running for a while and then it just hung somewhere, in this case, you could just enable the VM exit info and check what kind of guest behavior triggered the VM exit, and then compare to your guest early boot code. You could know, for example, when the guest is trying to write the control register, it will trigger the VM exit. You could know, you could map the VM exit info print on the print from the hypervisor, and with your guest boot code, you could know, you could guess a rough place where the guest boot start. And also you could use the command, the vCPU dump rec, to check the guest register, like RIP. Then you could know where the code is running, especially when if in some cases I saw a lot of that is the guest is just dead loop. You could see the IP will just change in a very small range. Typically it's like a dead loop in the guest. Any further questions? No. Okay. Okay, and also just like I said, we have a hypervisor command we could use to check the guest status, like dump the guest register. You could dump the guest memory, and also you could dump the pass-through device info and pass-through interrupt information. There's some special debug command we just introduced to our account to benefit our guest debugging. For example, we could inject exception to the guest to trigger something. For example, we could inject the general protection fault to the Windows. If you run the Windows guest, that will trigger the BSOD. In some cases, the Windows could dump their status to the storage. Then you could use the general Windows BSOD analysis method to check what's happening in the Windows. And also, you could inject the NMI to a Linux guest. You know, when the Linux kernel get NMI, it will just dump the current kernel backtrace. That's the Linux reaction to the NMI. One thing I need to say here. This special debug command is not integration, is not merged in our account master branch. It could be available in some release branch. Okay, question? Okay, I'll go next slide. Okay, we're talking about post-launch guest debugging. Now, post-launch guest is a little bit special. You know, it's launched by the account DM from the SOS. So we support all the guest self-debugging method. Like if you're running post-launch the Windows, the Windows debug with the the USB connection is available. You could use that, but that require the USB controller pass through to the Windows. And also the kernel logs, the kernel KGDB over Ethernet also is available to debug the post-launch Linux guest. And also the Android ADB, if you have the USB client controller available in your platform, and also it's enabled in the Android guest, so you still could use that after you pass through the USB controller to the Android guest. It still could be available for you to debug your Android guest. And the one limitation is that we don't expose the hardware debug infrastructure to the post-launch guest. That means the guest debugger cannot use the hardware debug infrastructure. For example, you cannot use the hardware breakpoint in the post-launch guest. If you do the debug a lot, some debugger implemented the software breakpoint just by just by replace the target instruction with some a GP instruction. Then they could just stop the application running there, right? But in some cases, you just only could use the hardware breakpoint to do that, especially when the code is write only, something like that. But if in the post-launch guest of the account, you cannot use the hardware breakpoint. But the software debug structure still can be used. Okay. Any other question? Okay. Yeah, we have some Archon extended debugging methodology here. Because one post-launch guest is actually mapped to an Archon device model process. The Archon post-launch guest is actually managed by the Archon device model running in the SOS. It's actually a process of that in the SOS. So we could trying to debug that process and to understand the guest behavior. For example, we could use GDB to attach the Archon DM, and then we could put some. We could set a breakpoint to some, for example, some IO port access. Then when the guest trying to access that output, we could stop the Archon DM, and we could know that the guest is trying to access this output. We could know what the value, whether it's read or write, and the value of read or write, right? And also we have the logger for the Archon DM. That means we have some kind of log mechanism in the Archon DM. So people could add the logs to the Archon DM. For example, you want to know how the guest is trying to access the storage. So then you could add some logs in the storage backend to print out the storage access offset or the access block size. Then you can know how the guest is trying to access the storage. Yeah, just this kind of information could help us to understand the guest behavior but it's not in the direct way. It's with the indirect way. And also some common link store could be used to understand the guest behavior. For example, the S trace. The trees also could be used to understand the Archon DM. So we could observe the Archon DM process behavior to understand the post-launch guest VM behavior. There's some limitation for this debugging methodology. The one thing is that if the operation, for example, if the guest operation is stuck in the hypervisor, then the Archon DM cannot observe that stuck. The hypervisor side operation is invisible to the Archon DM. And also, some function is limited if the post-launch guest has higher severity than the SOS. For example, if you have a higher severity RTVM running as post-launch guest, with the RTVM, there's special attribute like we pass through the local epic to the RTVM, and also we enable the volatile polling mode to the guest, so we cannot monitor what kind of volatile operation in the guest from the Archon DM, because all the operations polling in the guest in the post-launch VM itself. Okay, any question here? Here, I want to explain the thing a little bit here. So there's a question in the chat window about whether we could debug the hypervisor with the GDB. So yeah, hypervisor cannot use that to use GDB to debug Archon hypervisor. But here we are trying to debug the post-launch guest. So we could use GDB to debug Archon DM. But comparing to the QMU-based GDB, we lack some functionalities. For example, we cannot pull in the vCPU status. If you use the QMU and plus GDB to debug the guest, you could print out the guest status right from the GDB with the GDB connected to the QMU. But in our case, we don't support that level debugging, even it's the post-launch guest. Because to achieve that, we need to add some hype call to pull in all the guest status, like the vCPU status or the memory status, and then we transmit that information to the Archon DM. Then we check that through the GDB. That still need to add some code to the Archon hypervisor. Yeah, so we just don't add it. Oh, questions here? No.
Quick one. You've got a 10-minute left for your session.
Okay. Yeah. Summary for the Archon hypervisor debugging. Yeah, the first thing, we highly depends on the physical serial port, because the JTAG port is just very rare to the custom board or to the board we are using. So we highly depends on the physical serial port to debug the Archon hypervisor. And also to the guest, we don't expose any hardware supported the debugging infrastructure. So like, for example, you cannot use the hardware breakpoint in your guest. And the software-based debugging infrastructure is still available to the guest. Like I said, in some debugger, the breakpoint is implemented by replace the target instruction with the some fault trigger instruction. That one still works. So we still could use GDB to debug Archon DM in SOS. Yeah, we cannot do direct debugging, but we do have a lot of methodology to do indirect debugging method. In our case, we use the available debugging methodology in ACRN in our daily debugging work. Yep. Yeah. Okay. That's all for me. If you have any question, yeah.
Thank you for the presentation. If you have any question, people on the chat, please, or just unmute yourself. We have another, I think, well, roughly 7 minutes before we jump to the next session, so we have time.
No, okay. I'll stop the sharing.
Okay.
Back to you, Chief.
Thank you, Fengwei.
Sure.